All right? Is that good? Okay, great. Well, that's something, I'm going to tell you everything you ever wanted to know. It's sort of a good entry. We'll see if that's the case. What actually I'd like to do just real quickly is get a sense, how many of you in the audience are researchers? Students, scientists, okay. And then how many people would say you're more doing other kinds of support work to the research? Okay, so a few more people in that range. Okay. So when I put this together, I was actually mentally thinking about people who are doing the research, but I think that it is useful for folks in all different roles here at the lab. And if there are things that, there are gaps or things that we want to talk about, I think there'll be plenty of time at the end for questions, and we can interact on that. So I hope it is, in fact, interesting and helpful to all of you. So, everybody has seen the buses and seen the slogan, bringing science solutions to the world. That's, the Berkeley lab. And we've been doing it for 80 years, doing fantastic science and telling people about it, explaining it, revealing it to the world through our publications and other ways. But I would contend that these statements in red are equally as important, and that is that the full value of these discoveries can't really be realized until people actually use them. And sometimes it takes more than just reading the publications and building other science on top of that. And so we want to do everything we can to make sure our technology actually gets applied. And another way of describing this is just in the simple statement that, overall, not just at our lab, but throughout the world, basic science does lead to these game-changing discoveries and creates whole new industries, but that without transferring the technology, we don't get the total benefit to the taxpayers on their investment in scientific research. So it's one way to think about it, it's part of our social contract with all the people in our country who are paying for us to be here, that we get the maximum out of the science that we do with their funds. So the Berkeley Lab does engage with the private sector in a lot of different ways. Most of our funding here is from the Department of Energy. The next greatest amount is from the National Institutes of Health, and then there's some other federal agencies. But we also do collaborations, formal collaborations of various sorts with the private sector, with the companies. We do it through sponsored research, sometimes called work for others. We do it through CRADAs, which are cooperative research and development agreements. That's a way to collaborate formally within a contractual method. And it can either bring in funds or bring in expertise from a partner. We do it through user agreements, both non-proprietary and proprietary. Those are also very important ways of interacting and making our capabilities and our unique equipment available to people, whether it's in academia or other national labs or private companies. We also have companies who are participating through advisory and review committees. We do material transfer agreements. We bring in materials from companies. Sometimes they're materials that they give very few other people in the world. They won't even sell them, but they'll give them to us to do research. And that's based on our reputation, the reputation of RPIs and scientists. Also, sometimes we can get information from companies. So it's not actually materials, but it's data. It's other kinds of descriptions of things that, again, they're not sharing with the world, but they will give us as long as we keep it private of theirs. We also license our intellectual property, and that's what we'll be talking about more today, sort of what that whole process is like. We do a lot of informal collaborations. Our scientists in particular, I think, are very effective and eager to continue the collaborations. In many cases, they're ones they started when they were students, but at the drop of a hat, picking up a phone across the table in a cafe, talking about the science and collaborating with others outside of our organization. And finally, private consulting. The laboratory does allow individual employees to consult with companies or consult with others in their private capacity. It requires approval, but it is allowable, and we have over 100 people doing that at any given time. So that's another way we engage with the private sector. And so, as I said, today I would like to focus mostly on the very intellectual property heavy topic of licensing of intellectual property. We're very active in this area. Our laboratory holds over 300 active U.S. patents. We have, over the course of 10 or more years, promoted, that means marketed, told the world about over 500 inventions here at the laboratory. We have 600 active licenses in place. That means individual contracts for use of our technology by companies outside the lab. We've been the basis of 31 startup companies. I think that number might be old because I don't think it includes the latest 2 or 3 that we've done. And we've brought in royalty income of over $25 million in the last 10 years. Now, you know, like any good scientific topic, we have a model for technology transfer. This is a very simple and simplified model, but I think it's good for at least initial discussions, and so let me start with that. We start, you know, the idea of what we mostly think about, what we do here is our research, and this isn't just a model here, this is the model, I'd say, generally in research universities and national labs across the United States. So as we're doing our research, from time to time, an invention arises. Sometimes it's very intentional. We're looking for something, we're trying to discover something, or we need to create something as part of our research. Sometimes it's serendipity. You know, we're putting things together, we're trying out things, and all of a sudden we realize that we have invented a new material, a new procedure, a new something that didn't exist before. But an invention is the beginning of the intellectual property progress and ultimately a license. Concurrently with doing the academic research, of course, we're working on our publications, and that can continue for quite some time. And it's purposely here in parallel with this tech transfer path because that is, in fact, how it often occurs. As we've done the research or we've gotten to a point where we're going to start our publication, that's often where we realize we have an invention as well. The next step in it, and I'm going to talk about each of these, but the inventions have to be assessed. So just because we invented something, you know, it may truly be an invention, but it may or may not be something that is commercializable. You know, a company may or may not actually be willing to put any money in it. So that's part of the assessment. It's not an assessment for, is it good science? You know, it is a different kind of assessment, but that's a really key step. If that assessment results in an answer that says, yeah, we think this could be of some kind of commercial value, we would move into patenting it. We market the invention to tell the world about it. And again, these things don't necessarily come sequentially. Sometimes we've marketed them before we patented them because we weren't really sure. We need the market to tell us. If we're very fortunate and skilled, we like to think, then we do find a company that we can license the technology to, and ultimately, if that company is successful, we share in their success by bringing in royalties on the sales. There are basically 3 goals for technology transfer here at this lab, and these are in order of importance. The first and overarching goal is we are here and we're making these decisions, the assessment decisions, the patent decisions, the things I just talked about, based on how are we best going to be able to provide Berkeley lab technologies to industry to develop and commercialize for the benefit of society. So that's the overarching goal when we're making decisions, because this is all about making decisions. Secondly, we want to support the research mission of the lab. There are times when companies are willing to participate in the research. We're talking about some of those ways a little while ago. And they can and will do that in association with the opportunity to have access to intellectual property, to patents, licenses from them. And then lastly, not to be ignored, but it's definitely the third in priority order, we are looking to secure a fair return, a financial return, and then share that income with the inventors. Now, and these words are carefully chosen. We're not here to get the maximum return. We're not here to get the optimum return. We're here to get a fair return. So if somebody's going to make a lot of money based on lab technology, it's our philosophy that we should get a reasonable, a fair part of that. And so that's the approach we take. So what is the role of the researcher? Or maybe more broadly, the research division? There are a few things that need to be done in all of this to make sure that it gets off on the right foot. First of all, it's really, really important that people keep lab notebooks. This is sort of old school research 101, but it is phenomenally important that it can be paper or electronic. It can be, 21st century. It doesn't have to be the old-fashioned paper notebook. But if it is, it should be kept in ink. It should be bound, numbered, signed off, initialed, dated on each page. Shouldn't be erased, shouldn't be whited out. If there are errors, they should be lined out and just initialed. And the reason for that is that, let's put it this way. If the intellectual property isn't of any value, if there isn't an invention out of it, it doesn't matter. It doesn't matter if the person has kept a notebook like this. It only matters if something valuable comes out and you don't know in advance which of the experiments is going to be an underlying foundational experiment that will be of value. So that's why we really recommend that very strongly. And we have come into cases, but right now we're trying to support one of our licensees which is in a dispute with another company, and they've called out our lab notebooks as part of the evidence in that case. And so we've had to go back to the closets and find lab notebooks that are 10 years old and send them to the law firm, and that's going to be part of that settling that dispute. So it really does matter when it matters. Secondly, it's very important that inventions do get disclosed or reported to Tech Transfer, to my office. There's a place on the website you can go and just click on there. It should be before it's publicly disclosed. I'll talk a little bit about what does public disclosure mean. The reason for that is that as soon as an invention is publicly disclosed, you lose all rights to patent it in every country in the world except the United States. So we do have a little bit, we have a grace period in this country, but there is no opportunity to cover it in any other country because they demand absolute novelty. So very important to get that before it's publicly disclosed. And usually people find that the time that it's very convenient and appropriate to think about whether they have an invention is while a manuscript is being prepared. So again, if your job is perhaps assisting people preparing manuscripts, that would be something that you might think about talking to your research group about, are we really reviewing this for the possibility of invention? Because you're describing it right there, and really that's what an invention report or invention disclosure is. It's just a description of what that invention is. So you're doing a lot of that in preparing the manuscript anyway. Also, the same thing on reporting software to the Tech Transfer Department. That software is also intellectual property. And again, the time to think about, well, when should I do that? I'm coding all the time. The time to think about that particularly is when you're getting ready to send a copy of the code, a link to the code, to somebody on the outside. So enough of it is done that it's of value to somebody, otherwise you wouldn't be sending it. And that's probably the time that would be good to disclose it to our office. Another role of the researcher or person in the research division is to provide any market insight that you might have to help target the invention to potential companies. Sometimes you have no idea. That's fine. Sometimes because of interactions with people at conferences or what you've read or with your ex-students or whatever, you might have some good ideas on places that are real opportunities to link up and provide the intellectual property. And finally, there are quite a lot of times when people at the laboratory are offered agreements to sign. Confidentiality agreements, non-disclosure agreements, material transfer agreements. They should be referred to our office. There's an amazing array of things that companies might ask you to sign off on, and we are happy to either execute those if they are fine and not troubling for the university or laboratory, or to negotiate them with the other entity. So you shouldn't be on the hook for any of that. Just send it to our office, and we will pursue them. So I mentioned that assessment is a really important step in this. So somebody has an invention, they describe the invention, they send the report in to us, and we have to decide what are we going to do with it. We don't have the resources to pursue a patent application on every invention. So we have to be careful and a bit choosy on that. So again, we're not looking for, is this the quality, which piece of science is the highest quality. What we're looking for is which invention might have a commercial value so that a company would want to take it out and develop it further. So these are some of the things that we look at. Does it provide a new or improved solution to an existing problem or market niche? So is there a demand out there already? People have been looking to solve this problem, and bingo, you've solved it. Does it address an unmet need? Again, is there a market for it? And what is the best way to commercialize the technology? There are times when the best way is really through just a free transfer. We do in software, for instance. Sometimes we do open source software licensing. That means anybody can get it if they agree to the license. They get it for free. They get all of the source code. That can be the best. There are other cases where that's not a good way to transfer it, and we're not really getting all of those criteria met, and we want to commercialize it and license it out, what we call commercially. Are there issues of patentability or public disclosure? So despite my exhortation to please get the inventions into the technology transfer department before the publication, it doesn't always happen. Sometimes people get busy, they forget, whatever, and so we do have to look and see if it's already been disclosed in some way. We look at what is the stage of development. If this is still just a concept, it might be, number one, difficult to get a patent on it, and number two, even if you did, it wouldn't really be fleshed out enough that it would be of much value. So that's one of the things that we will actually enter into a conversation about before we would move forward. And finally, just looking at things, there may be a market for it. It sort of met one of the earlier criteria, but is the market of any reasonable size? And what are the risks and what would it take? What are the barriers to entry of the market? So another thing that we have to do is find a licensee. So let's say we've had the invention, we've assessed that it looks like it could be pretty good. How do we come up with somebody who is going to actually invest in it? Because this is it's a business proposition. There has to be enough value in it that somebody wants to put some money into it. So we have a group in our department called the marketing group to identify various commercial markets and hopefully the competing products to try to identify existing companies that might be interested. We prepare marketing summaries. So, you have this description of your science, description of the invention. That's usually not what a company is looking for. The people in the company would be looking for the business case. So not, that this is the formula, but rather this is going to be better, faster, cheaper by 10%, by an order of magnitude, by, whatever that happens to be. So it's that kind of description that we have to prepare, to do an analysis, prepare that. And what we do is we put it on our website. We also email it out to companies that we have in our database. We also, another way that we find licensees is sometimes through the scientists themselves publishing or presenting at conferences, and people will come up to them at the end of the conference and say, well, or at the end of their presentation and say, well, that is pretty interesting, let's talk about it some more. And if that person is from a company that could commercialize it, that's another lead. And then, of course, industry contacts that might already exist. So we have a section on our website. Looks like this. Technologies available for license. They are, those one-page summaries I was just talking about. The business case for the technology is on those and in different topic areas. Up until, I'd say, perhaps 5 years ago, most of the connections were made by the scientist or the tech transfer office or somebody else at the lab knowing the right places to reach out and connect with people and companies. More and more, with all of the business and all of the living that goes on the internet, we're finding that companies are finding us. So, this presence becomes more and more important. It was just a few years ago we were contacted by a cooperative from the Basque region of Spain that came to us and said, oh, I see you have something in the area of solid oxide fuel cells. We're interested in that. And what was interesting is, well, of course, we would never have marketed to them. We didn't know they existed. Well, they would never have come to us either because they didn't know we existed. They'd never heard of the Lawrence Berkeley National Lab. I know that's sort of stunning that somebody hadn't heard of us, but they hadn't. But they had just been doing their search on the web, and they found our technologies. And they ended up supporting the researchers, providing some research and taking rights to that technology in Europe. So what we're finding, like as I said, even though we do email things out, people are sort of interested. More and more companies, customers, they want what they want when they want it, not just when we happen to have it available. So this is really important that they find us. So we license a number of different kinds of intellectual property. We license patents, patent applications. Sometimes, it's before the patent is even issued. That cover new materials, new methods, new processes. We license out biological materials, cell lines, transgenic animals. I already talked a little bit about software, and I will show you an example in a minute on that. And we also license out, from time to time, drawings, designs, images, mask works. So we're reasonably creative and can take things in a lot of different manifestations and license them out. I mentioned that it was important to tell us about inventions before they're publicly disclosed. And I'm often asked, well, what does that mean? Does that mean, when my publication goes out? And of course, that is one of the ways that things are publicly disclosed through the old-fashioned, journal publication. But it can also be a poster presentation. It can be the thesis or dissertation that the student writes once it is accessible. So once it's cataloged in a library and anybody can access it, it's considered to be a public disclosure. Our scientists are more and more often interviewed on TV, on radio. They present to different kinds of audiences, outside the lab. It's not a problem if it's to people here at the lab, so people shouldn't worry about presenting to their research group, even presenting to other colleagues at the laboratory. But to people who are not part of the laboratory, or at least part of the University of California, that could be considered a public disclosure. Even just a casual conversation, if you tell enough about it in one of these informal conversations, if it's to somebody else who's outside of it, it's considered to have been made public. So you're no longer just keeping it to yourself. And sometimes there's enough in even just an abstract to disclose an invention. So if it tells, really is the nub of the idea. So somebody else, if you're a chemist and another chemist could pick it up and say, I never thought of that, but now that I see this this formula, now I know what I would do and how I can make it as well. Those are things that are almost always public disclosures. Occasionally, some of these other things are also public disclosures. A grant proposal to a federal agency. The federal government is required to keep things confidential if we tell them that they're confidential. So any page that has confidential information, you're proposing, it's your idea, it's something new, it might be a new invention. If that's what it is, then it should be marked as confidential. There are sometimes, in the request for proposal, they will, have instructions on how to do that, and that's what we should follow. Also, you should always be aware that even though the proposal, we can, hold that as confidential, if you're so lucky as to have gotten the grant, usually the title in the abstract will be published somewhere, and so you can't protect that. So that would be one other thing to consider. And finally, a report to your sponsor could be considered a public disclosure. Not always, but that could be a concern. So it just, back on the same path, please, if you're going to disclose it to everybody else, please disclose it to the tech transfer office. Yeah.
Disclosure. So our group is a user facility, and our sponsors are industry. And so when they ask us what the cost is to subscribe to our program, when we send that information, should we also put in that in what we send them? The market is confidential. Will that protect our information from being passed out?
So the question was when an industry user at a user facility asks for information, and in particular for your rates, should you be writing that that's confidential? I wouldn't think so. I wouldn't think our rates would be something that I would worry about. If it was...
We are in competition with others.
Mm-hmm. But I believe that because we would give that information to anybody and everybody, unless you are tailoring the rates to each person who inquires, it's a little hard for me to think of why that would end up being confidential. Yeah. Interesting question. Well, thank you.
I have a question on how
Yeah.
you suggest on the public abstract and titles, how do you suggest handling that so it's not public?
Yeah. So the question, and I'm going to repeat the questions because they're trying to record this. So the question was on the titles and abstracts. How do we keep from getting in trouble on those? And we'll actually, we have patent attorneys in our office who will review those. And, it's not infrequent that we will ask people to, can you reword this just slightly to make it a little less specific so people can't just pick it up and run with it, because sometimes that's all it takes. In fact, we had a review for DOE about 2 weeks ago in which they were bringing in reviewers from the outside as a program review here at the lab, and they wanted to provide a list of all the invention disclosures that the lab had come up with, and I think this might have been for BER, so Office of Science. They wanted to have all the inventions to show what great, productive work was being done in complement with the publications. And we reviewed that list of invention titles, and I think we tweaked a couple of them and said, gee, can you just call it this? It still gives you the essence of it without the specificity. So we're happy to do that. That's what I would suggest. Okay. I often get questions about timing. How long does it take? How long does it take to transfer the technology? And of course, that's sort of a general thing, but it really is quite variable. So some cases are really quick. I mean, there are times when an invention will come in, and we already know people who are eager for that. They've been asking us, you say, you sure you don't have anything new in photovoltaics? And when the invention comes in, we know at least one party is very interested because they've been beating us down. And so after we've advertised it enough to meet our obligations to be fair, we have licensees who are willing to take it and are just sort of breathing down our neck. Other times, it takes years and years and years because we come up with inventions that industry isn't ready for yet. So we had an invention in the area of burners. It's a combustion invention, which would allow a burner to produce much lower levels of various nitrogen oxides. And so it was a real breakthrough. It was great. Problem was there was no driver. There was no economic driver for companies to start using those really low polluting burners. And there was no regulatory driver yet. And so it took over 10 years for that invention to, get its first licensee, just because, so just because we invented it and just because it was great doesn't mean that the industry will be quite ready for it. Also, just in the area of patents themselves, let's leave aside whether things ever get licensed. The U.S. Patent and Trademark Office now takes about 3 years to get back to us on just their first response. So we write up an application, which is sort of like writing a publication, right? It's a new piece of prose that describes the inventions in a certain way. We send it in to the U.S. Patent and Trademark Office, and then they respond, and we get an office action. That's their response. And it usually takes about 3 years to get the first response. That's the backlog. So if you think that it's taking a long time to hear what happened to your invention, you're right. It's taken a really long time.
So what happens when it takes that long?
What happens when it takes that long?
Like if someone else is also thinking of an invention and they come up with a very similar idea and you haven't patented it yet.
So the question is, what happens? It takes a long time. Other people are also working in the field. They might come up with the same invention, and then it depends both on the law is in the process of changing right now. Up until this year, we've been what's called a first to invent jurisdiction. So whoever came up with it first. Remember the thing I talked about, the lab notebooks? Really important because that's what shows that you invented it first. So if another entity also goes and tries to patent it, the patent office can look and see who invented it first. Now it's who is the first to file is presumed to be the first inventor. And so it is important to get there early. But you're right, and that does happen, that people will come in and also apply for a patent, and then you'll get it because you were first. Is the short answer. Another question that often comes up about income, I mentioned that we have inventions, we patent them, if we license them, eventually somebody sells a product, what happens? Well, we take a royalty. And on the net of the royalty, and when I say net is, first we have to reimburse the patent costs. So a lot of times we use outside attorneys and we have to pay for them. But after we've netted that out, we share the income, it's 35% to the inventors, and that's as a personal, to them personally. 15% to the research division or divisions from which the invention arose, and 50% to the lab director. And that's funds that can be used here at the lab. It doesn't go back to DOE, it doesn't go to UC, Office of the President, it stays here at the lab. And it can be used for R&D, it can be used for tech transfer, it can be used for education. So it's one of those kinds of money that is very, very attractive because it comes in without a lot of strings and without a scope of work. So when we want to start something new, this is a great source of it. I mentioned earlier that we have over 31 licensed startups based on Berkeley lab technologies, and a couple of years ago we took a look. We tried to track them, but we took a look, and at that point there were about 2,400 new jobs that we could directly find within those startup companies. So these are companies that, but for our technology, would not exist. And it weren't just some company who was out there and was kind of limping along, but they started up specifically to commercialize the Berkeley lab technology. And so there are ones that are local. CO is a battery company, used to be in Berkeley. I think they've moved down to Hayward or someplace a little farther south. Alphabet Energy is a waste heat recovery company. We're headquartered in San Francisco. PolyPlus, one of our oldest licensees, might be the oldest licensee, battery company here in Berkeley. Some of them have been acquired. So Aeroseal, interesting case. That's a company that took a technology that, for our lab, sounded kind of low-tech. It basically seals up the gaps in your heating or air conditioning ducts so that you don't lose heat. So you're not just running your furnace and then heating the outside world. So, and it was a startup company. They had a franchise model. They got acquired by an international company called Carrier, which is the largest heating and air conditioning company in the world. They were their own division. Then Carrier lost interest. They spun it out again. Now it's a separate company again. And it's based in the Midwest at the moment. And they have franchises throughout the United States and Canada. So I think they will keep going. So there's a different story about all of these. But it's I think, really encouraging to see this part of, our contribution to the economy. We also, as I say, talk to a lot of companies. So that's another thing that Tech Transfer does in association with the research divisions. We bring in companies that either we invite in or companies that find us and say, hey, I think you guys might have something that would be worthwhile to us. Can we come in? And we host them, talk to them about the technologies, give them tours, that sort of thing. The lab has really changed over the years in terms of its interest in intellectual property. I'll go ahead and add this one. You can see this is from, 1994 till about 2004. We went anywhere from about 60 to 80 new inventions a year. Pretty flat. It would go up and down, but really not much variation. And I've been in tech transfer a long time, so I was around here then as well. It didn't matter. It didn't seem to matter what I do. I'd come out and talk to people, large groups, small groups. Other people would do that. We would put articles in the precursor to table, all that kind of stuff. But we got this step change here. And does anybody remember what happened at the end of 2004? We've got a new lab director. A guy named Steve Chu. Anybody remember Steve Chu? Yeah. So Dr. Chu came here at the end of 2004, and I had a really interesting meeting with him because I thought, great, new director, let me tell him all about this stuff that we do. It's really important, really interesting. It's where I live. I want him to know about. And so I told him about this, among other things, and he said, 70 inventions, out of this whole lab. I think we had more than that out of my building at Stanford. Let's see if we can't do something about that. And so he did two things. One thing he did is he put on the annual supplement to the professional resume. That's the employee worksheet that all the researchers have to fill out, all the staff scientists have to fill out. Besides a little box that said, what publications did you do last year? He asked the question, what inventions did you have? What patents issued on your work? So all of a sudden, there was another box for people to fill out and something for them to think about. So that was the first thing he did. And then the second thing he did concurrently is when scientists would come into his office or into his conference room and pitch a new technology idea, a new research idea, is usually how it was couched. They usually had some background, so, well, I've done this so far. Now I have this idea for a great new initiative. And he'd say, that's interesting. Have you reported that as an invention to tech transfer? And, when the lab director does that, guess what happens? People pay attention. And so I think everybody not only was inventing, but they were pulling stuff out of their drawers they'd never thought of before and got that. And then it sort of went down because it was like, oh, okay, good, we got over that, we did that. And no, I'm serious. I think we should be doing this. And so then we got back up, to, again, a pretty flat rate but at double the rate. And I don't know if we are now entering another, higher level plateau. We'll see in the next couple of years. But the point is, there's a lot of creativity, a lot of inventiveness here, and there are ways to get at it. And this is just sort of one of the indicators I want to show. I also mentioned before that sometimes the best way to get technology out isn't a standard commercial license. So I want, again, to let you know, we're very serious about this. And so we also write licenses for free, free software licenses. And this has been something that has increased dramatically over the years. This has gone up to, I think, this almost 120,000 in a year. So these are people downloading free software packages developed here at the Lawrence Berkeley National Lab. And so we're able to count them and capture this. Obviously we don't know what they did with them, but these are, to a great extent, packages of energy efficiency kinds of software. So hoping people are using those. So let me just, I'm going to wrap up here, I think, with just a couple of examples. One out of your division, the Phoenix software. That's I think, a great example. We have both licenses of the software and support through sponsored research from over 15 companies now, pharmaceutical and biotech. This is a protein crystallography software that's being built with both NIH money and corporate money. So again, great way to get the information out, get the software and its capability out, and bring in funds to continue the research. Another example, a startup company based on some technology. Now, this is not PBD, but also life sciences from Mina Bissell and her collaborator, Eva. Basis of a startup company called Progiderm. And this is a factor that basically they discovered, which increases the subcutaneous fat. So it's the fat that we have, or young people have, right under their skin, and makes it look sort of full and youthful. And that you don't have so much if you have been harmed, if you've been, had a either disease or fire or some other, gross injury. And the hope and the expectation is that this can restart the growth of that to, again, create a surface that people will be happy with. And then the last example, I just wanted to talk a little bit about the technologies that have been coming out of JBay. And I think, again, this audience should be very familiar with JBay as a partnership among 6 entities, 3 labs, 3 universities. I think we're adding another lab shortly. But basically to, start with sunshine, end with fuel. That's the idea. And what they have been very active in is inventing. So along with the research, along with the publications, this was just at the end of FY11. They had 87 inventions in 4 years. We had 44 of them patent applications, over 20 that the applications were being negotiated for licenses, and 4 complete licenses or options. And this is at twice the national average rate of major universities. And the same thing with the percentage of patent applications actually being licensed or in negotiation with licenses. This is a little bit of more detail on this model, and again, I added this as well because it just shows more current numbers. So instead of 80-some inventions, actually now we're up to 122. We have 2 startup companies that are originated by inventors at JBay. We have 1 startup company that was developed by somebody outside of JBay, but they took one of our technologies and started up their own company. And we have 2 more that are on the startup track, that we're talking with, they're developing, and I think we're going to have companies come out of that. So, again, very exciting things. I had a couple more items. I'm just going to talk about some more recent things we're trying to do to increase people's knowledge about the commercial opportunity and so on for their technologies. But rather than talk about these, I wanted to leave a minute or two for questions. And I realize we're almost out of time. So let me do that and ask you if you have some questions. Let me do that before we run out. Yes.
If you have programmers that are doing sort of like a lateral log online, there's really nothing to sign or nothing to have physically. How do you prove that that they actually wrote it at that time?
Right. So the question was, if you have people who are basically doing everything online, it's not like having a physical notebook that they can sign and date. How do you do that? There are a number of research groups at the lab, but that's all they do is they just do everything electronic. In fact, at JBay, I think that's what they are doing right now. So there are systems in place to do that. I should probably get back to you with more information on that, but it does work. The people, end up with sort of date and time stamps on their work so that we can, and even review, because that's the other part, is that, to have a really great record, you have the information, the work that was done by an individual, and then somebody else comes and says, hey, I've witnessed that. Yes, in fact, this did exist at that day. I saw it. So we should get back to you. But yes, that's perfectly fine to have it done electronically. Anything else that people have a question about? Yeah.
So how much does it cost to do patent applications and technology transfers and stuff? It seems like there are a lot of people involved in it. It would be expensive. So, are we covering the costs of doing that? If you said that we made $24 million in royalties over the last 10 years, it doesn't seem like very much when you consider how much
Right.
Staff
Yeah.
are worth and lawyers are expensive and that kind of thing. And I'm sure patents cost a lot too.
Right. So the question was, how expensive is all this, and are we making money, or are we breaking even? And so the easy answer is no, we're not making money. This is not a money-making operation. The money that we do make offsets a lot of the costs, and as they say, sometimes the winners pay for a lot of the losers, because even if you only patent half of your IP, the fact is you don't know which of the, and you license out half of that, you don't know which half you're ultimately going to be able to license. You just don't have that kind of crystal ball. To give you just sort of a, but it's not terrible. So to give you just a order of magnitude notion, our budget last year was about $3.5 million. The internal staff and the external patents and all that kind of stuff. And we brought in about $3 million. Now, again, some of that we brought in, we gave to the researchers. So it wasn't that we brought in $3 million that we could just push into the overhead. But it's close. A patent application, if you're just doing it with external counsel, and we do have internal counsel, we have about 4 patent attorneys, so we do most of our work internally, especially if it hasn't been licensed out yet. Externally, it costs about $15,000. Yes.
As a scientist, not so much as software licensing, but the project, do they talk to prospective customers or whatever about buying or using their equipment, or does tech transfer represent them?
So the question is, did the scientists actually talk to some of these companies who ultimately might license the technology or participate? And they absolutely do. They're certainly allowed to talk to anybody they want to. What the best arrangement that we can figure out so far is, as companies either approach us or we find them, we try to, I don't know what you want to say, qualify them first. Sometimes there are some people who are just, science nerds, and they just like to talk about science to all kinds of people, and we don't want to necessarily waste our scientists' time if it doesn't look like there's much possibility. But except for that, then we'll try to give them, the company or the entrepreneur, the first bit of information, however much we can, and if it's going to get serious, try to marry them up with the scientists, because there's always going to be more questions, more information that's not there in the publication. They really need to have that conversation. Yeah.
And then who sets the price? Does the inventor or does the lab?
Yeah. So the question is, who sets the price? Tech transfer sets the price. So the inventors are not involved at all in the negotiation or in the business arrangement. As you can imagine, they'd be personally conflicted because they have a chance to gain personally from the financial interests. So we're the ones who decide that. And it's decided through negotiation. There's not a set price. It's each technology has to sort of stand on its own, on what it might be worth, what things go for in the market, that sort of thing. Any other questions? Well, I hope that this has gotten your interest, and I certainly invite you, if questions occur to you later, please just contact me directly and we can have that conversation, or I can introduce you to somebody else in the department who might be able to give you more specific information. For instance, the question about the electronic notebooks and that sort of thing. So thanks a lot. I really appreciate your attention.